Hello, friends. Welcome to the second video of learning semantic kernel in AI with Supreet. Yesterday, we saw our first video where we saw how to load the kernel and the basics of it. We created a simple prompt and we used that prompt in a function. Now, I want to talk about this function before we go ahead and start on today's project. This function that we created is called a semantic function, and as I said in the last video, there are two kind of functions that we can use with semantic kernel. One is the semantic functions, the second ones are the native functions. What is the difference between the two? Well, the primary difference between the two is that semantic functions are the functions where you are basically using AI. You are calling one of the open AI or other AI services to get something related to the AI done. Consider this as the brain of your application. The second thing is the native functions. Native functions are anything that you do otherwise with your code. These could be your REST calls, this could be your API calls, this could be your complex logic that you handle in your application. Anything that you otherwise do in your application and create a function for it, these are native functions. Okay, so have that understanding in place that semantic functions are the functions which are your functions wherein we use AI to use one of the LLM capabilities, and native functions are those wherein we use everything else that we have always been doing with our programming, be it REST calls or any other programming logic that we have in place or that we want to use. With that in mind, yesterday what we did is we created a new function using one very simple prompt. Right now, while this was a good way to get started, when you are creating practical LLM based applications, it is not going to be as practical to create prompts using C sharp. You may probably need to do that when you want to create the prompts dynamically, but in situations where the prompts do not need to be created dynamically, you can actually predefine these prompts and load them from a file. That is what we will be doing today. So let's get started. To get started, what we are going to do is we are going to go ahead and start a new application again, and we will be creating a console application once again, and I will call this escape prompt demo. Okay, so we will create a console application as we did previously, and we will start from scratch. So this is a console application. There is nothing in there, as you can see. So the very first thing that we will do is we'll go ahead to the tools, and we will go to the NuGet package manager, and we will install our favorite package here, which is, you guessed it right, semantic kernel. All right, so we will just go ahead and install this very quickly in our project. I will approve and accept. Now this is installed. Yeah, that's installed. Great. Now let's go back, delete everything. And as usual, we need these two using statements using Microsoft dot semantic kernel and using Microsoft dot semantic kernel dot connectors dot OpenAI, because we want to use the OpenAI services. Now, before we go ahead and start creating the kernel as we did yesterday, what we need to do is we need the Azure configuration in place. So what I'm going to do is I'm going to very quickly copy and paste my Azure configuration from the text file, and I am going to blur this so that my data is not visible to you. But yeah, there we go. So now that we have our basic the configuration in place, I just copy pasted the configuration. And if you remember what we need the endpoint, we need the name of the deployment from Azure AI Studio, and we also need to know what the underlying model that we are using. You need these three things to work with semantic kernel and using Azure AI with OpenAI basically. So yeah, we are using OpenAI, but we will be using Azure AI in this case. So okay, so now that we have that in place, let's go ahead and go back to our code, and again we will try to do this in as less steps as possible, and I will try and explain each and every step as we go along. So the first step is to create the builder. So we will just use the kernel object here, Microsoft Semantic Kernel, and we'll use the create builder method on top of it to create a builder out of it. Then the next thing that we will do is we will use the config, and we will provide it the Azure config to use the deployment name, the endpoint, and the API key that I already have copied here on top of the screen, which is not visible to you by design. So our builder now knows like what are the configurations that we need to use, and then finally what we will do is we will go ahead and create a kernel using builder.build method. Once we have the kernel, now remember what we did yesterday. After this, and after this we created our prompt. Today what we are going to do is we are going to play it a little differently. We do not want to create a prompt and a function out of the prompt in the code, but we want to create the prompt statically in our application, and we want to load that from the file. So how do you do that? Semantic kernel provides a fantastic structure to do that. It's very easy. Just go ahead to your solution explorer and create a new folder called plugin. So I will go ahead and create a new folder called plugins. This is where all our plugins will reside. And plugins are nothing but bunch of semantic functions that you want to use in your application. So I'm going to go ahead and create my first plugin, and we will call it fun plugin. I am keeping it as close to the samples provided in the Microsoft Learn resources, so that when you are going through the samples and when you are revisiting these videos along with the Learn samples, you are able to map what we are doing there. Okay, so what we have done is we have created a folder called plugins. Inside of that, I have just created one plugin for time being, and it's called fun plugin. Inside that fun plugin, I've created a folder called joke. Now, this is where it gets interesting. This joke is my function, and this is the name of my function. And in this case, if you remember it, this is a semantic function, and semantic function is the one wherein we use the AI capabilities, right? So we can have multiple inside of the plugins folder. We can have multiple such plugins. Each of the plugin may have one or more functions, and each of the functions can do one of the specific jobs that based on the prompt that you give it to. Okay, so for time being, let's have one plugin, and inside of that only one function. Inside of this, now let's add two files. One is going to be a text file, so I'll go ahead and add a text file here, and we will give it, and you have to be very specific in terms of the name. So the name of this text file always have to be sk prompt, semantic kernel prompt. This is where the prompt will live, so you put that there, and then we will also add a JSON file here. Why this JSON file? This JSON file is basically going to be the configuration, execution configuration. This is the file that tells our semantic kernel and the LLM that what is the name? The name is config.json. So we will add that there. Right now, what are these two files? Let me go ahead and revisit them very quickly. So skprompt.txt is where the prompt will live, right? And let's go ahead and do that. In fact, so I'll just go back to my notepad, and I will go ahead and copy the prompt from here. So my prompt here is this, and as you can see, this is a static prompt where we are asking that write exactly one joke or a humorous story about the given topic. And the joke must be G-rated. It should be workplace and family safe, no sexism, racism, or other kind of a bias, and be creative because I want to laugh. Again, I have copied these prompts from our Microsoft Learn repository. I'm keeping it as close to the Learn repository as possible. And here, if you notice, I'm giving it two parameters. One is an optional parameter where you incorporate the style suggestion if provided. And if you remember in our yesterday's code, let me go back and open that once again for you. And if you remember here, you see this is how we created the input token. this is how we create a parameter to be passed inside of the prompt. We are using the exact same method today as well, but instead of doing that in C sharp, we are creating it in the skprompt text file. So we create the style um, token over here, which basically is one of the optional parameters for this prompt. And as we said that we want the joke to be created based on the topic below, and the topic is this one input here, right? And these are just delimiters, so it separates rest of the prompt from the input. You can write it however you want. The llms are smart enough to understand, but it's a good idea to keep it this way. So skprompt.text is where your actual prompt goes along with any optional and mandatory arguments or input parameters, right? So that is the job of that file. And in config.json, this is where we basically tell LLM what exactly is my function, what is the name of the function, what is the job of the function, what how many parameters are there. All of those details go in there. So I'll just delete that there. And you see that I have this schema. It's called schema 1. I have the description. The description is to generate a funny joke. Then execution settings. Again, these are the execution settings. If you remember in our code yesterday, we had these execution settings over here wherein we said that max token is equal to 100. It's the same thing. Now we are doing that via the JSON file. So the execution setting is there. Max tokens 1000, temperature zero point 0.9. Temperature is it's a variable. If you keep it as close to zero, the llm will give you very rigid answers. It will be as close to the fact as it can be, wherein if you bring it towards one, it will be as creative as possible, it will be as random as possible. So you basically control the temperature. If you control the temperature, you basically control the randomness of the output or the result that the llm will generate for you. So because this is a joke, I want it to be towards on the random most side. So we have given it zero point 0.9. We will leave the rest of the execution parameters like that. And then if you remember in our escape prompt, we had two different variables, right? So we'll have to give it these input variables. Then the first one is input, and this is the subject of the joke. There's no default value. The second one is an optional one. It's the style. In it says that given the hint of the if the hint is given, then use that style for the joke, right? Okay. So that's the entire structure. Now you don't have to worry about memorizing the structure. This structure is pretty much the same. So it's a good idea to just have a template and copy paste it, and then change the values based on that actual prompt, and then based on the prompt, change the settings accordingly. Okay, now that we have that ready, our next step is to go ahead and use the prompt that we have created just now, and load it. So I'm gonna go ahead and I'm going to copy this. Step number 4. In step number 4, what we are going to do is we are going to load our plugin that we just created. And how we will do that is we will create a parameter here, and I'll just copy these two. In fact, step number 4 and 5 here. So what we are doing here is we created a directory path.combine. We are using system.io directory, get current directory, and then I'm going up so that I go back to the root. So if I use the current directory, it will take me to the bin folder of this setup. Then I need to come out from that folder thrice to reach the plugins folder. Then I'll go into the plugins, and then inside of plugins, I should find fun plugin. Inside of plugins, I should find fun plugin. So that's how it will be able to find the path of my plugin, where my prompt is, my plugin is residing in the file directory. Once I have that path, the next step, fifth step, is that we will use the kernel objects, import plugin from prompt directory method, and pass this path of the plugin to it. What it does basically is that it does the same thing. It loads that prompt and we have already also updated that this is the joke is the function that we want to use inside of the fun plugin. Okay, so now that that is all done, the next job is to go ahead and construct the argument. because if you remember, our prompt requires one mandatory argument, and that is the input, right? So we will create an argument which would be a kernel argument. We will give it the name, and this name is exactly the same that we have given in our SQL. If you see this here, it's the same thing. So make sure that it is the same. Then the input is I'm just giving it some random string here. I'm saying that the Bollywood has lots of songs in the movies, right? A lot of them, even when they are not needed. So yeah, I want the system to create a joke on that. Okay, so we pass that as an input, and let's see what kind of a joke it creates. And finally, the last thing we will do is we will go ahead and run. So running the code is again the seventh and the final step. Okay, it was not by design that then again we were able to finish this entire lesson in less than 7 steps, which is fantastic. So run the function, and in function, what we are going to do is we are going to use the kernel, and again we use the invoke async method. Yesterday also we did the same thing, use the kernel and invoke async method, and then we call the summarize method that we had yesterday in our previous video, and we pass the input parameter there. Today we are doing exactly the same thing, kernel dot invoke async, and then we are giving it the name of the method, and then we are giving this is the name of the method, and then the arguments we are passing that here, and then that's all. So let's go ahead and run this, shall we? Let's see what kind of a joke do we get today. All right, so is it running? Yeah, it's running. I hope it works. Let's see. And it's not breaking yet. Am I getting a result? Yeah, we have a result. Why did the Bollywood singer refuse to sing any more songs for movies? Because he was tired of being asked to sing the same old tunes with different lyrics. That's a sarcastic one. So you see that how easy it is to go ahead and create semantic kernel based AI enabled projects. And in this video, we noticed how instead of creating the prompt and the function right within the C sharp, how you can create a static prompt in and read it from the file directory. So again, let's go ahead and revisit. We first added the NuGets, then we created a kernel, then we created a builder object, and then we provided it the Azure settings, and then we used the build method to create the kernel object, and then finally we uh, created the path for our plugin. And how it is done in semantic kernel is you have to create a plugins folder. Inside of that, you can have one or more plugins. In this example, we have only one plugin. Inside of that, you have to create another folder, and you can have multiple folders for each of your functions. One function requires one folder, right? So joke is a function, so we needed one folder for that. So joke is the function here, and inside each of these semantic functions, remember what is a semantic function? A semantic function is the one wherein you are using AI capabilities. It's different than the native functions, right? So in each of these functions, we have a config.json and an skprompt.txt. The names of the file needs to be exactly the same. That's how semantic kernel knows that okay, this is a function and this is where the prompt is. And from there, it becomes really very easy. You use this kernel.import plugin from prompt directory method to create a function out of it, and a plugin out of it. And then once the plugin is created, you create an argument and use the kernel's invoke async method to give it the path of the plugin, the function, and the arguments, and that's all. There you have the joke. Well, that's it in this video. Thank you very much. I'll see you again in the next video of semantic kernel, where we will learn even more advanced topics. So up until then, bye bye.